Uh, I'm Naufal Islam, and a bunch of physics students apparently are struggling with final velocity. I don't, so I'll try to help. I doubt I will. Alright, so I'm gonna teach you guys, not really teach, but I'm gonna demonstrate two types of final velocity. Yeah. Okay, so if you want to conceptually understand final velocity, it's the velocity before the end of the motion of an object. So like there's something moving, right? Final velocity is the velocity at the end, near the end of that object's motion. So first of all, I'm going to start by writing the formula for final velocity. Then we'll plug in these values and solve it. So I'm going to teach you the formula for final velocity. Final velocity equals initial velocity. Now, initial velocity is the velocity that starts at the motion of an object. Plus the acceleration multiplied by the time. This is the formula for final velocity, where acceleration and time are given. Now we've got the formula out of the way. I've explained it, and you hopefully understand it now. I'm gonna demonstrate how to solve an equation using this formula with the information given in the equation. Alright, so typically these are the types of equations you're usually gonna get if you're doing like a physics exam or anything like that. You're gonna get typically these types of equations. Not equations, damn it, problems, I meant, sorry. So it's actually very simple. Like, I'm being serious. It's very simple. Damn camera, can't focus. And my shadow's in the way. Damn it! I'm probably gonna cut that part out. Anyway, rewrite the formula. And then you're gonna plug in the values that were given here. I'm gonna explain all of it. We're gonna rewrite the formula with all the values given here in the formula. Then we're gonna solve it. Alright, so when we rewrite it, we're gonna get final velocity, of course, but for the initial velocity. So remember what I said, initial velocity is the velocity at the start of an object's motion. Here it says a car starts from rest. Now rest in physics means that it's not moving at all. It's, well, rest. So the velocity would be 0. Initial velocity would be 0 since it's starting from rest. You should memorize this, always keep this in mind. Rest for initial velocity means 0. Or it means that there's no velocity at all. And it accelerates uniformly at 3 meters per second squared. Here we're gonna add the acceleration multiplied with time. 3 meters per second squared. I'll just write 3. It's way simpler and we don't need to see all that. And then the time, 6 seconds. Okay, now we just solve this. And the final velocity will come out to 18 meters per second. That will be the final velocity. Now this was really simple. I know all of you can agree with that. This was really simple, correct? Yes, correct. And learning this is fundamental to kinematics. So we'll move on to something a little more challenging. I'm going to demonstrate final velocity, where time is not a given factor in the problem you need to solve. Here, time was given 6 seconds. Here, there is no time. So, before all that, I'll write down the formula. Final velocity squared equals initial velocity squared plus 2 times a times displacement. S is the kinematic symbol for displacement. I don't know why it's not D. Oh, wait, actually, because D is the kinematic symbol for distance, and S is displacement. Don't ask why. I don't make the rules. I just teach you them. Anyway, yeah, to be honest, I can't really explain this part myself because I didn't really conceptually understand. I didn't really conceptually learn yet what each part of these mean, but as you can see, there's no time in this equation. I told you that in the beginning of this video I might not be that much of a help, and you're probably seeing that now. I'll explain as much as I can for the formula. If you want to conceptually understand it, go to a real physics teacher. I'm just going to teach you how to use it and plug in the values to solve it. So final velocity, we know what that is because I've said that earlier. We square it, and then, but that's at the end. And then it equals initial velocity. We square that once we get it. And then we add 2 multiplied with the acceleration multiplied with the displacement. So now something I'm going to teach you here is sometimes, occasionally, okay, before that I'll actually rewrite the, reread through the problem. A bike accelerates from an initial velocity. Remember initial velocity? Sometimes it'll be written as rest if it's 0. Other times it could be written as initial velocity of 0. Some people might do that. I don't know why. But just be wary, that can happen as well. From an initial velocity of 10 meters per second with a constant acceleration. That means the acceleration isn't fluctuating between different values. It's constant. 4 meters per second squared over a 10-meter distance. Now, this is the part I want to talk to you about, distance. Because before I said S stands for displacement, correct? D stands for distance. The reason why, I actually don't know the reason why some people put in distance instead of displacement, but it doesn't really matter because you can treat, if you see distance, you can treat it as displacement and everything will go according to plan. So just don't get thrown off, do not get thrown off by that if it says distance or displacement. Just remember the formula. Don't get thrown off by that if you encounter it. And then it asked me to find the final velocity. So what I'm gonna do is rewrite the formula. What was it? Oh, I'm looking through my phone while recording, so I can't really see the other part of the formula. Do this at the top of my head. All right. Now we're gonna plug in the values like we always do. Initial velocity of 10 meters per second squared. With a constant acceleration of 4 meters per second, then you multiply that with the displacement or distance. In this case, it's distance, which is 10. And then this would just turn to 100. And yeah. But wait, we're not over yet. You remember learning Pythagorean theorem back in elementary school? You remember how you had to find the root of the c value? A squared plus b squared equals c squared, and then you had to square root. You had to find the root of the square root of c. You got to do that here, because once you solve all of this, you're gonna get a final velocity, but that isn't the correct final velocity that relates to the equation here, because the values are smaller than whatever the final velocity would be once you solve all of this. You're gonna have to square the final velocity. So we'll rewrite the equation again. Damn it, focus camera. Final velocity equals 40, 80, 180. And now we gotta find the square root of 180. And to be honest, I can't do that at the top of my head. And I'm too lazy to walk and get a calculator. So I'll let you, the viewer, figure out the final velocity of this equation right here. Also, I was gonna get into terminal velocity, but to be honest, I haven't fully mastered terminal velocity. So yeah. I hope this video helped. If it didn't, that's unfortunate. You should watch a better teacher. I'm really not a teacher. I'm not even a physics student yet, because I'm in grade 8 currently. I'm in 8th grade currently. I am no high school where I live currently teaches 8th grade students kinematics or physics. So yeah, that's gonna be it. Bye.